All right, so here we go. I'm going to read this off to you because this is an application type problem. And so it says, a room in a museum has a semi-elliptical dome with a major axis of 50 feet and a semi-minor axis of 12 feet. A light is placed on one focus of the ellipse, and the light that reflects off the ceiling will be directed to the other focus. The museum curator wants to place a sculpture so that the sculpture is at the other focus where it will be illuminated by the light. It says choose a coordinate system so that the ellipse is oriented with the horizontal major axis with the center placed at 0, 0. Write an equation of the semi-ellipse. Okay. Okay, so let's see. So we have the graph. Okay, so here. So we've got this. So I just drew the diagram. So here's the way we have it set up. We've got 50 feet length here. We've got 6-foot walls, and then the ellipse or the semi-ellipse begins, right? And so we know that that height from the center line here up is 12. So this is going to be the length of the semi-minor axis, right? And then we've got this here. So a couple of things. Oh, where's my marker? Oh, I left it over here. So one thing to note is they want us to give an equation. So we're going to assume that right in the center here is 0, 0. Right? So that's going to be our center. If we were to envision, right, the center line going right through there, right? So that would mean what? Remember, half the length of the major axis is A. So that would tell us that A has to be equal to 25. They're giving us the length of the semi-minor axis, which is right here. So B is equal to 12. And so if we're going to write this and we're going to assume that this is the origin, right, 0, 0, then our equation for the ellipse is going to be x over 25 squared, x squared over 25 over 25 squared, and y squared over 12 squared. And that will equal 1. All right, so there's the equation they want us to use. Or in other words, let's just write it the way we should, which is x squared over 625 plus y squared over 144 is equal to 1. Okay, now, so that was the first part of the question, right? So now the second part, the second part says what? It says, approximately where should the sculpture be placed? Okay, well, we've got to find the focus, right? we've got to find where this is located right here. Okay? So again, we're 6 feet from the floor, so we're going to assume that's on the 0 line, right? So we just need to know how far from this 25-foot range here, right? Because from the center, 25 feet. Okay? So now we need to find where the foci are located. Okay? Or at least find our C value. Well, we know the A and B, so let's just use our C squared equals A squared minus B squared. And so we know that this is going to be equal to 625 minus 144, which is going to be equal to 419. No, 481. Okay. And so we take the square root of that, so C equals the square root of 481, and if you stick that in your calculator, what do we get? We get approximately plus or minus 21.9 feet. Okay, so that means what was it? 29 point, oh, let me check again. 21.9 feet. Okay, so it should be at 21.9 feet from the center, right? So that would be 21.9 feet from the center of the room. Or you could also say it should be placed, 3.1 feet from the wall. And then of course 6 feet up, okay? So, but that's where you should that's where you should have the statue placed to get the light. All right, that's it.